Action now. So warm-up number 40, we're done with that. Your agenda, warm-up number 40, rational functions, page 459, home plate only. Your code for your presentation today, BQM72. And that was last night's home plate. You turned that in. Tonight's home plate, page 459. All right, get a Cornell note ready, please. You don't need a prayer model since you already know the definitions and such. I can solve rational equations. I can solve rational equations. And let's see some of your responses. I have someone that said, an equation that contains rational expressions. Okay. Not bad. An equation that contains one or more rational expressions. Okay. Fractions with polynomials. Yes, but remember to finish in equations. In equations, because there has to be an equation. Fractions with polynomials set as an equation. Okay, not bad. An equation that has one or more rational expressions. Equation with two or more polynomials as fractions. Okay. Equation that contains one or more rational expression, and so on and so forth. All right? Pretty good? So, we know what they are. Gave you guys all these yesterday. Gave you guys steps. If it's a proportion, once again, remind your neighbor, what is a proportion? Remind your neighbor, what is a proportion? What is a proportion? So your neighbor, proportion. What is a proportion? Jaden, proportion. Equation, yes, it's an equation, but what kind? Very specific. Help them. Fraction equal to? Fraction, yes. One fraction equal to another fraction. That's when we cross multiply. However, what if it's not, Mr. Q? I gave you guys these 3 steps to follow. Find the common denominator, multiply the entire equation by the LCD, and simplify and solve. Okay? So, yesterday we did this one, this one, this one, this one, and we left off on some that look like this, but copy this one, example 2 super Q. Copy this one. It reads 2 over y plus 1 plus 1 over y plus 1 equals 4 over y. I just want to make sure that we got the process right. So by looking at it, tell your neighbor if that is a proportion. Tell your neighbor if that's a proportion. Is that a proportion? All right. Is that a proportion, Jaylene? No, it's not a proportion. Why not, Jacob? More than 2 fractions, yes. We have 2 fractions equal to 1 fraction, so that can't be a proportion. So we go straight to identifying the LCD. So over here on the side, if you have red, we're going to start with LCD. LCD. Let's write our denominators. Y plus 1. The other one is y plus 1, and the other one is y. So let's look at the first one. Can we factor this one anymore? No, so let's set it in parentheses. The second one? No, set it in a parentheses. So let's look at the first 2. What do you guys notice? They're the same, so these are common. So our common denominator is y plus 1 in parentheses. Bring down y. So be careful with these, because I wanted to bring this one up because it's going to happen. If I ask the question, what does this one need that this one has, some of you are going to say plus 1. We can't do that. We can only multiply. We can't add or subtract. Let me repeat that again. We can only multiply. We can't add or subtract. Let me repeat that one more time. We can only multiply. We cannot add or subtract. Therefore, let me go the opposite way. What does this one have that this one needs? Well, it needs a y. Therefore, what does this one have now that this one needs? y plus 1. So my common denominator now for all of it, y plus 1. So with that said, now that we have our LCD, we multiply the entire equation times that, but only the what? The numerators, yes? So my LCD is y plus 1. All right, I'll give you a head start so you can multiply that in really quick or set it up. All right, so let's see. Hopefully you rewrote the fraction again. The first one was 2 over y plus 1, yes? But since we're going to distribute the common denominator to the first fraction, we're going to multiply times y plus 1. Second fraction, 1 in the numerator, denominator y plus 1. So that means we're going to distribute this times the second numerator. So this is times y plus 1. Equal 4 over y. And then we distribute the LCD. So this is times y plus 1. All right, now that we're there, tell your neighbor the next thing that we're going to do. What do we do next? What do we do next? All right, what do we do next, Noah? Say it again. We already multiplied, yes, here it is. But look at it. Do you notice anything that we can do at each giant one? Yes. So therefore, do you notice the first one? Yes. How about the second one? Yes. How about the third one? Yes. So that leaves us with 2y plus 1y equals 4 parentheses y plus 1. Let's simplify. 2y plus 1y, that's 3y. What do we do here? Distribute, so that is 4y plus 1. All right? Tell your neighbor what to do from there. What do we do from there? What do we do from there? Yes? What is it? 4y plus 4? Yeah, I did that to see if you guys were paying attention. 4y plus 4. All right. What do we do from there? Danny, go. Subtract 4y from both sides. Subtract 4y from both sides. That leaves us with negative 1y equals to 4. And last but not least, everyone, divide by negative 1. So y equals negative 4. All right. How we doing? Kind of, sort of, yeah? So if you notice from the home play, I think these are the ones that gave you the most problems, even though it was only 2 of them. Okay, tonight you're going to have also another 2, just FYI. Are we done? No, Mr. Q. All right. Excluded values. Tell your neighbor what to write for excluded values. What do we write for excluded values? What do we write for excluded values? All right, tell your neighbor already? Okay, good. Help us out. Bailey, what do I write? y plus 1 equal to 0. Y plus 1 again, but since we already have it, we're not going to redo it. And then e equal to 0. So therefore, minus 1, y equals negative 1, and y equals 0. Excluded values, negative 1 and 0. Yes? All right. So how are we feeling now with these? From 1 to 5, how come through are we? 4 or 5, 4 or 5. Okay, we need practice. All right. But here's where I want to go. Write this word down. Extraneous solution. Extraneous solution. Extraneous solution. That's like a big word, huh? Extraneous. Well, it's not that big. Kind of like my last name, Quintanilla, right? Extraneous. What is an extraneous solution, Mr. Q? Well, if the solution to the rational equation, think about it, if you solve an equation and the solution is an excluded value, can you use it? No, that's what we call an extraneous solution. Write that down, please. If you solve the rational equation and the solution is an excluded value, then you cannot use it. Huh, Anthony? Okay, good. And you're writing that down. My goodness. Ah. Once again, if you solve the rational equation and at the end you go to the excluded values and the solution is an excluded value, then you cannot use it. It's an extraneous solution. Extraneous. 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 Forever. Have you guys watched that movie? Forever. Forever. No? You guys watch? No? What? Let's go. Yeah, that's a classic. All right, we good? Once again, if you solve the rational equation and then you find the excluded values and one of the solutions or the solutions are excluded, then that's known as a what? Extraneous solution. So, let's do, let's do this one. Example number 3. 1 over x plus 1 plus x over x minus 3 equals 12 over x squared minus 2x minus 3. Should be on your screen. So, do we have a proportion? Yes, no, maybe so? No, because we have 2 fractions now equal to 1 fraction. Therefore, we go straight to our what? LCD. We got x plus 1, x minus 3, and x squared minus 2x minus 3. All right, so let's factor first. Look at the first one. X plus 1, can we factor this anymore? No, so we just put it in parentheses. Can we factor this one anymore? No. So question, what does this one need that the other one has? X minus 3. What does this one have that this one needs? X plus 1. So my LCD for these two is x plus 3, x plus 1. So far so good, yes? All right, next. Let's bring this one down, but before we bring it down, let's factor it. Negative 3, negative 2. Yes? X minus 3. All right, thank you. X minus 3. There it is. All right. So, what 2 factors of negative 3 add up to give us negative 2? 2. Tell your neighbor. Factors of negative 3 that add up to give us negative 2. Selena, go. 1 and negative 3. So my factors are x plus 1, x minus 3. And what do you guys notice? Same. So my LCD is x minus 3, x plus 1. And that's what we're going to use to multiply times the numerators. X minus 3, x plus 1. I'll give you a head start. Let's see how you do with that. All right, help me out. What did you write for the first fraction? Laura, tell me what you write. What goes here? All right, x minus 3, x plus 1. But I'm just going to rewrite the fraction as it was with a 1 and x plus 1. Okay? Plus, next fraction. Miroslava, what do I write? X times x minus 3, x plus 1 over x minus 3. Last fraction. What do I write, Danelli? Twelve times x minus 3, x plus 1. And on the denominator, guys, I can write this or I can factor it. Do we know the factors of that already? Yes? Which are x minus 3, x plus 1. So, any giant ones? Yes? Yeah. Right here, and right there. So that leaves us with 1 times x minus 3 is x minus 3, x times x plus 1, and over here just 12. All right, let's simplify. Distribute, so that is x minus 3 plus x squared plus x equals 12. Can I combine stuff? On the left side, yes, so we have x squared plus x is 2x minus 3 equals 12. We have a quadratic equation. That means we need everything on that side, yes? So tell your neighbor what to do, please. Make sure they got it. What do we do next? What do we do next, Kimberly? Yeah, subtract 12. That leaves us with x squared plus 2x minus 15 equal to 0. Negative 15, positive 2. What factors of 15, negative 15 give us positive 2? Negative 3 and 5. All right, x minus 3, x plus 5. Finish it off. What do we do from there? Maya G, what do I write? X minus 3 equal to 0, x plus 5 equal to 0, so therefore plus 3, x equals 3. Minus 5, x equals negative 5. Excluded values. Do we have any? What do I write? Brandon, Darty, tell me what you write. X plus what equals to 0? x minus 3 equal to 0. And that other one becomes these two, yes? All right, so minus 1, x equals negative 1, plus 3, x equals 3. Look up. Question. Do we have any solutions that are part of the excluded values? Yeah, which one? This one. There it is. So that means we cannot use that one. It's known as extraneous. How's everyone? Enjoy your home play. See you guys tomorrow. Bye. Woo. Today was packed, Jaden. Go.